This conference will now be recorded.
Hello guys, today we'll continue the electrolysis. Now we will talk about half equations. What are the half equations? As you see from the PowerPoint, that redox reactions involve transfer of electrons, as I said before, losing or gaining electron, or what we call them oxidation or reduction reactions. Equations written to show that what happens to the electrons during oxidation and reduction are called half equations. They are not different things. As from previous example, we were showing that what happens to the elements. They are losing electron, they are gaining electron. Now this time we will show them in the equations, or we will write them as an equation. So how we will write them? For example, let's start from the point. Show half equations. Let's write half equations. Half equations and show. So let's write our example. Magnesium plus oxygen. We took the balanced equation, so I will write the balance to magnesium oxide. So half equation. Again, half equation represents which element is reduced or which element is oxidized. Reduced or which element is oxidized. Just we are showing them in equation. So let's check. Again, you can do it by oxygen or you can do it by magnesium. But in half equations, you have to show these electrons. So you have to find their charge first. Elemental form. Magnesium is at elemental form 0. Oxygen is at elemental form 0. Ionic compound. So you have to say that magnesium second group +2, oxygen sixth group -2. Remember, yes, here magnesium is second group 2, but this elemental form. So you don't need to include any charge above elements or molecules. So, but here it is they made ionic compound. So inside ionic compound, we have ions. So they have to have a charge here, each magnesium and oxygen. So what happens to these elements? Magnesium. Magnesium goes from 0 to +2. So what happens to the magnesium? If you remember before, we said that if the charge increases, it is oxidation. Charge increases, yes, but how we will show the oxidation? Oxidation, what was the meaning of oxidation? Oily, loss of electron. Yes, how we are showing loss of electron? You put arrow, and on the right side of it, you write +2 electrons. Fisher, what's the meaning of this +2? Why we are not writing this +2 electron near the magnesium 0? Because electrons, as you know, they are negatively charged. So if you will write +2 plus -2, what you will get? 0. Again, as all chemical equations are balanced electrically and a number of elements, so if you will check this part, it is total charge is 0 and it is 0. So because of in oxidation, we have to write electron on the right side of the equation, not left side. Because if you write here +2, it will be 0 plus -2, it will be -2, not +2. So in oxidation reaction, we are writing the electron on the right side of the equation. And also electron lost from the element. But this is oxidation. Oxidation. First part of half equation. Second part, oxygen here. Oxygen negative is 0 here. Sorry. Oxygen goes to the elemental form, which is negatively. And you see that I am not writing directly the arrow. First, I have to identify its oxidation or reduction. Just write elements and their charge forms on the each side of the equation, on the right and left side or product or reactant side. Oxygen goes from 0 to -2. It charge decreases here. So decreasing charge means gaining of electron. So how we show gaining of electron here? As we showed the magnesium 0 to get -2, what I have to write? +2 electron, because +2 electron means that 0 plus -2. So it is reduction. So oxygen is reduced, but this is and those known mistakes what our students are doing here. If you will not check the number of elements here, you will get incorrect calculation. Why? Because there are 2 oxygens here, but there is only 1 oxygen. So as we say that all chemical reaction has to be balanced, you have to first balance the element. Here there are 2 oxygens, there is only 1 oxygen. So you have to put here 2. Now this time, things have changed. How have changed? Now this time on the right side, we have -4. Here we have -4 electrons. But here there is 0. So what you have to write? +4 electrons. Please just be careful here. +4 electrons. First, we balance the elements. As you see, metals, I didn't do this because metals are making, at the start of electrons, I have said to you, metals are making just elements. The elemental form of the elements are the same as they are found in the periodic table. But in non-metals, they are not same. Non-metals are mostly found as diatomic form. So first, I have to balance the elements. Second, you have to balance number of electrons. So what has happened here? Reduction. So this is called half equation. Half equation of magnesium and oxygen reaction. Half equation of magnesium and oxygen reaction. For example, let's do some examples and explain. For example, aluminium plus 3 goes to aluminium 0. It gains 3 electrons. 3 plus -3 means it goes to 0. It's gaining electron means reduction. Magnesium goes from +2 to and gains 2 electrons. Gaining electrons is reduction. Oxygen, as you see, it is balanced. It's correct because sometimes they are giving us given question that what's the incorrect place of this equation or in this equation. So oxygen goes -4, 2 times -2 to oxygen 0, and it loses electrons, so it is oxidation. Again, if it is written on the right side, it is losing. If it is written on the left side, reactant side, gaining, that's all. So it is type of oxidation and reduction reaction. So these questions you can do by yourself at home to practice redox reactions. Redox reactions. For example, I will show you one example again about the redox reactions. Another example. Another example. So let's see. Aluminium plus chloride molecule makes aluminium chloride. So if I will balance here, 2 here, 3 here, 2 here. What happens to aluminium? Charge. Aluminium goes from 0, 0, +3, -1. Aluminium goes from +0 to +3. 0 to +3. What happens to the aluminium? 0 to +3, charge increase, so I have to show oxidation, +3 electron. Chlorine, I will just show like this. Chlorine 2, 0 goes to the chloride, -1. I will not show this balanced form. So what happens to chlorine? First, you have to balance non-metals. So there are 2 chlorines here, only 1 chlorine. So you have to put 2 in front of it. 0 to -1, it gains electron, but how many electrons will gain? Because on the right side, you have -2, you have +2 electrons. So it is oxidized, or oxidation process. So it is reduction process. So this is redox. This is the half equation of aluminium chloride without balance. If you will balance, you have 2, 2, 3, 3 here, but there will be 6 electrons here. And there will be 6 electrons here. Okay, the moving ions. Ionic compounds are made of positive and metallized and negative non-metallized. Ions in sodium. What are ions in sodium chloride? As you see, sodium glass and chloride. It is a salt which you are making, which you are eating at home. So negative ions in ionic compound attract each other strongly. It takes a lot of energy to separate them. We know this from the first ionic compounds. Again, it is a multiple. In the scabs. So they are made of ionic compounds. They are made of ionic lattice. They are solid at room temperature. They have high melting and boiling point. They are soluble in water. They conduct electricity when they are molten liquid. Blah blah blah. You can do these questions at home. So Do molten ionic compounds conduct electricity? Do molten ionic compounds conduct electricity? Let's see. So we have lead bromide, lead to bromide here. Lead to bromide is solid ionic compound. As we said before, that solid ionic compounds will not conduct electricity. So why it will not conduct electricity? If you, as we said, the bulb it didn't light up. Why? Because solid ionic, solid lead to bromide, yes, it has ions, but ions are not able to move freely. Why? Because they have giant ionic lattices and they are tightly packed to each other. But if you will start melting the heating the lead to bromide and at the end we will melt it, what will happen? So because of its molten, ions will start to move very freely and it will conduct electricity. As you see, bulb light up here. Why it conducts electricity? Ions in lead to bromide, lead plus 2 ions and bromide negative ion will start to move freely and then they will conduct electricity very well. So what will be produced here? Brown gas, which is bromine, will be produced here, and a liquid reverse as a bead of gray metal is produced. Gray metal is our silver here. So if you look at the summary, molten lead bromide conducts electricity. The current causes it to break down and form new substances. The products are lead and bromine. So as you see that, we can split molten or aqueous solution. In aqueous solution, for example, sodium chloride. Sodium chloride, again, which is at solid state, it will not conduct electricity. Why? Again, ions are not able to move freely. Let's see now. So, as you see, we switch the button on, but it does conduct electricity. But if you will dissolve the sodium chloride inside the water, so what will happen? Dissolving means solvent dissolves the solid, and by stirring rod, we are making the fast dissolving. Then, if you will switch on the current, so what will happen? It will bulb light up. So what we are observing here? There is a green gas and bubbles are produced on the different charged electrodes. I will explain what's electrode here. So what happened here? Has happened here? Sodium chloride conducts electricity. Why? Because firstly, it has sodium plus and chloride ions. Now look at the behind of the ions. There is H2O, water molecules here. As you remember from this at the start of covalent compounds and by the way, ionic compounds, we say that why ionic compounds are soluble in water? Because when you are dissolving them in water, the water starts to split ionic compounds into their ions. So the ions are becoming able to move freely, so they will conduct electricity very well. So green gas forms at the positive electrode and a colorless gas forms at the negative electrode. So you have the produce chlorine, hydrogen, sodium hydroxide. We will talk about them further. So that is happening conductivity. So now copper sulfate solution conducts. Crystals do not, because crystal means solid state. Solid do not. Solid do not. Molten, yes. Solution, yes. Molten, yes. So this is easiest way to identify it conducts electricity, ionic compounds conduct electricity or not. Electrolysis of molten ionic compounds. Yes, as we said before, that electrolysis means splitting up ionic compounds into their ions to make an element or molecule. So Greek word meaning is splitting by electricity. Electrode has many uses. We can use it for purification of copper, plating the metals with silver or gold, extracting reactive metals such as aluminium, and making chlorine, hydrogen, or sodium hydroxide. It's our future lessons. So, what is electrolysis apparatus consist of or made of? So this is very important. Try to have this picture in your books. Now I will offer you a video material which will be expensive. This is enough, I think, for us. So let's go to electrolysis. 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 As I said, we're splitting ion compound into their ions. Electrolysis takes place in electrolysis apparatus. What's electrolysis apparatus? Electrolysis apparatus consists of first of an electrolyte. I will explain what are the electrolyte. Electrolysis apparatus consists of two oppositely charged electrodes to oppositely charged electrodes. What is the oppositely charged electrons here? Positive and negative. These are electrodes. Okay, and these electrodes are connected to each other. Conduct electricity. This is called electrolysis apparatus or electrolytic cell or electrolytic cell. I hope all of you can see this. Electrolytic cell. Firstly, what is electrode? Electrode, let's go back here. Electrodes is an inert material that conducts electricity. The inert material that conducts electricity. Inert. The new word for you is inert. What does inert mean? Inert means unreactive. Inert means unreactive. Inert means unreactive. Which electrodes we have or we are using in electrolysis? Either graphite or platinum. PT. Graphite, which is raw material carbon. Why we are using graphite or platinum? Because they are inert. But why mostly graphite we will use? Because graphite is cheaper than platinum. Okay, this is the cheapest material in the world, for example. Now, electrodes are inert materials, graphite or platinum, doesn't matter. Of course, you use a graphite because it is cheaper. What is electrolyte? Electrolyte is a molten or aqueous solutions of ionic compounds. Ionic compounds. Why ionic compounds? Because ionic compounds have ions inside them, so you make element or molecule from them. So this is electrolytic cell or electrolysis apparatus. Consists of electrolyte, which is solution here, or molten form of the ionic compound. We have electrodes, which are inert materials that conduct electricity. Let the electricity pass through it to split up ionic compound, and they are oppositely charged. And the electrodes are mostly made of graphite or platinum. What happens but in electrolysis? What happens in electrolysis? How the electrolysis works? Let's say that I will delete this one. Electrolytic cell, graphite or platinum. We say that we have to use an electrolyte. For example, sodium chloride again. Sodium chloride is a, let's say we are using a molten or aqueous solution, doesn't matter, molten solution, sodium chloride. Sodium chloride consists of two types of ions. What are they? Sodium plus and chloride ion, as I wrote before. We are splitting sodium chloride into ions, molten sodium chloride. So what I have here, I have a cation and I have an anion. Yes, I have cation and anion. So I have two types of electrodes, positively charged and negatively charged. First, let's learn their names. As we have learned redox reaction by simple word, which is oily, we can remember this name of these electrodes and their properties by using just simply panning word. What is panning here? Panning is positive. Positive is anode word new. Negative is cathode. Negative is cathode. This word we have to remember here. So my positively charged electrode is an anode. Negatively charged electrode is cathode. So Here you have to work with your logic, or which method is easy for you. You can use this. There are two methods to remember. To which electrodes these ions will move. Why these ions have to go to each electrode? Because they are free now. Sodium plus. Let's say I have now split sodium chloride compound here, molten compound. You have sodium plus, and you have chloride negative, chloride negative, chloride negative. Here. These ions are freely moving inside the solution. They have to be attached to electrodes. But which electrodes they will go? First method, how to remember? Remember their capital letters or symbol, cat or Ca. Cation will go to the cathode, anion will go to the anode. As you see, their capital letters or words are the same, cathode and anode. Or other method, cations are positive, they have to go to the cathode. Why? Because cathode is negatively charged. So cathode will affect positively charged ions. So sodium plus ions will be collected over the cathode. Is it clear? I think it's clear because cathode is negative charged electrode. It will affect positively charged ion because they are opposite charged. Always remember, cat goes to the cathode, anion goes to the anode. Anions are negatively charged. They have to be affected by positively charged ions. So chloride ions will go towards the anode. Negative, I mean Cl, let's write Cl negative, Cl negative, Cl negative, Cl and negative. But what happens at the end? What was the definition of electrolysis? Electrolysis feeds ionic molten or electrolysis ionic compounds into their ions. As you see, we have split sodium chloride. But at the end, what we have to make? An element, which is sodium, which metals are making always element, or a molecule, which is Cl2 gas. So chlorine will make a chlorine gas, Cl2, which will be collected over the anode as a green gas. Sodium plus will gain electron and it will make what? Sodium element at the cathode as a metallic form. So what has happened here? Sodium went from +1 to 0. Charge is 0 here. So +1 to 0, what happens to the charge? Charge decreases. So when sodium goes to the sodium 0, what has happened to the sodium? It get reduced. So reduction takes place here. Reduced. But chlorine went from -1 to chlorine 0, it gets oxidized. So what we can understand from here? We can easily say that, according to our example, at the cathode, always reduction takes place, always. At the anode, oxidation takes place. This is very important rule which we have to remember. At the anode, oxidation takes place here. Why we have explained it? Because positive ions are going to the cathode because cathode is negative. Positive ion is metal. Metal has to gain electron to become a metal element, so it gets reduced. Reduction takes place here. Negative ion goes to the anode because it is positive. It gets oxidized by losing electron. There's a loss of electron here, so it is oxidation. So electrolysis is a type of redox reaction. Reduction and oxidation takes place here at the same time.